Okay, welcome to the kitchen again. We're here today to talk about Alfred Wegener, a scientist who in the early part of the 20th century proposed a theory called Continental Drift that helped explain, in his eyes, helped explain how the continents look the way they do. And he proposed basically that in the system of the continents drifting apart, continually crashing into each other and moving around the surface of the Earth. And I just want to go through pieces of evidence that we used to put forward this theory. So, first amongst these was fossil evidence. So this is a mesosaur, and it looks like it's something that obviously swims in water, as you can see here, but it's actually a freshwater dinosaur, and they were basically fossils of this animal found in quite different parts of the Earth. I've got an image that shows this in a sec. So if we look at the next image, we can see that the parts of the Earth where the mesosaur fossils are found, it was found in southern tip of Africa, which obviously is down here according to where the world looks now, but also in this quite southern part of South America. So looking at where the world is now, it's all this area here. And he's proposed that these continents must have been joined together if this fossil can be found in both these places. So that's the mesosaur. And also there was another couple of animals that we used to provide evidence for this. So this scary looking beast is called Arthroplura. It's a millipede, and this would be around about 1.5 meters long, around about sort of this wide, pretty big thing. And the fossils for this animal, I've actually seen these myself actually. And the first one, the fossil was found for this, was this place. This is a photograph taken at a little place called Lagan Cove on the Isle of Arran. And just to give you a bit of context, that is about there. And then you can see in this photo here that you've got, you've got these tracks of, you can see these footprints here that come across the rock, and these are basically trace fossils of this massive millipede. You can see how far they are apart based on the scale of the person in the background. There's really been quite a large animal. And so these sort of disappear into the sea on the west coast of Scotland. And then, next photo. So I'm sure it's a little bit small here, we'll blow it up a little bit, let's get a little bit bigger. And you can see that this, quite similar fossils, and it's not the same individual, but these fossil prints are very clearly from an extremely similar, if not the same species. And this was found at a place called Nova Scotia, which is basically over here in Canada. So another piece of evidence that showed that this species, which couldn't have swum that distance, the land masses must have been joined. So there's two pieces of good evidence. Another one is this, that if you look at mountain chains around the world, so the Appalachian Mountains, which are over here in the eastern USA, and also the edge of Greenland and the Caledonian Mountains of Scandinavia and British Isles, and also the west coast of Africa, all those mountain areas, they've got very, very similar rock structures and very similar types of rock. So again, they probably must have been formed when these land masses were joined together. So that's the second piece of evidence, the rock record. But thirdly, it's quite a commonly espoused theory. You can see, look how closely that the coast of certain areas of continents just fit together. And if you go beyond the actual edge of the rock itself and look at the continental shelf, the shallow underwater edge of the continents, they fit together even better. So that's basically what evidence he put forward as to how this must have been joined together. And then this wasn't really proved. A lot of people disagreed with this theory, but in the 1950s, the Mid-Atlantic Ridge, which is shown in light blue on this depth of water map here, this had been long surveyed from the late 1800s, but by the 1950s it was actually properly surveyed and mapped, and it showed that this was an area that was spreading, was moving apart, which basically almost proved Wegener's theory. But it took a long time. It took about 50 years for his theory to be proved. There we go.